Good morning. It is 9:30, and so we are going to begin our third annual online conference. And we have just had a beautiful weekend here. It's been a gorgeous late fall weekend. Hope you had the same wherever you are. And we have a wonderful list of panelists today, and I'm just going to go through some housekeeping things before Steve Young helps us dive in. Let me have a look here. You can put your questions in anytime. There's a Q&A feature on Zoom. If you scroll your mouse over the bottom of your window or over the top of your window, you'll see there's a little box that says Q&A on it. You can click on that and ask a question. And there's also a possibility to do that anonymously. When you put it in, you can see that there's an option where it says question anonymously. So please feel free to use that. And we can go through the questions. We have 5-minute presentations, and then we have 5 minutes or 10 minutes each half hour for your questions. So dive in and ask as much as you would like. We also have a new feature at the Northeastern IPM called Find a Colleague, where you can enter your details of who you are and what kind of work you do and who you're looking for. And then you'll be able to match up with other people in the Northeast that you could collaborate on projects with. And the links for that are up there and will also be at the end of this presentation. And there's going to be an archive of today's webinar. It's being recorded, and you'll also be able to get a copy of the slide set. And that's going to be available at this link. And again, we'll put this on at the end of the webinar. So with that, I will turn it over to Steve Young, and he is going to lead us through today.
Great. Thank you, Jana. Just want to let everyone know that I'm actually not even in the Northeast right now, so this virtual kind of connection is really valuable to be able to kind of bring this information to people across the country, across the world, who knows. But yeah, just happy that everyone can join us today and learn more about IPM and what people are doing. And I think Jana might have mentioned this, but this is a collaborative effort between our center and really the Northeast SARE and all the programs that they do, the programs that we do, as well as the NIFA, USDA NIFA, and their crop protection pest management program. So we look at this as really a collaborative effort across the region and across the different programs. So I'm really excited about this. I'm excited to hear from a lot of different folks and a lot of different projects. And hopefully you are too. We've done this, as Jana said, this is our 3rd year at this. And it's really a fascinating thing to hear what people are doing. And it's really just a snapshot. And I really would like to remind speakers that we are going to hold you to 5 minutes, because that's how we keep this going. So just keep track of time. I'm going to kind of, maybe cut you off at 5 minutes, but hopefully none of you run over, just to keep everything going smoothly. So I see on my clock it says 9:34, so I'm going to go ahead and start just a minute early, and we're going to go right into hear from Changlu Wang. And this is a project that has been funded by the Northeastern IPM Center, reducing pest infestations and insecticide residues in low-income housing at Rutgers University. So Changlu, take it away.
Yes, good morning. Can you hear me?
Yes.
Okay. Welcome everybody. Thank you for participating in this webinar. My name is Changlu Wang. I'm glad that this year we received a 1-year project to develop aesthetic injury level for German cockroach IPM. As you know, German cockroach is the #1 indoor pest in the US. It's not only a nuisance pest, but also can cause asthma and can vector hundreds of pathogens. As a result, it's considered an important indoor pest. However, different people have different tolerance levels. 2 critical steps in the cockroach IPM is to determine the presence of a cockroach population, and also to determine when people begin to react to the infestation. So in this study, we have three objectives. The first is to determine the aesthetic injury level for German cockroach management in apartment buildings. For this objective, we selected 369 apartments. We inspected every apartment for the presence of cockroaches and laid traps for 2 weeks. Then we also interviewed the residents when they are available. And this we can allow us to establish a relationship between, between the people's sighting of cockroaches and the trap counts. Go to the next step. So next slide. Okay, thank you. So the second objective is to determine the association between AIL and presence of current cockroach infestation, and also the association between AIL and the apartment condition, such as sanitation. We know that a lot of people would have different views about when cockroaches should be controlled. This can vary among different race, different gender, or people with different sanitation conditions in their apartments. So we would interview different people, especially in the low-income housing. There are Hispanic, Black, and white people. So all across these three races, we'll analyze the association between the race and the AIL. Next slide. So the third objective is to see if we can use the non-chemical control only to eliminate the cockroach infestation in the low-level infestations. So we know that about 50% of the infestations have very low-level populations. So, most people would use sprays to control cockroaches. Can we use trap alone to eliminate the infestation? So in this objective, we selected a total 53 apartments. Half was treated by bait, half was treated by traps only. Then we recorded the trap counts for 3 months. This study is already finished in the field part. Right now we are analyzing the data. So, so far we found that trapping alone had a similar effect on the bait alone treatment. We also found that there are some association between the race and presence of cockroach infestations. So we anticipate that this project will help reduce the insecticide applications by using traps instead of using baits. We also can use this information to help reduce the cockroach management cost, because we can then use AIL to determine when we treat the apartments. We don't have to treat every apartment every month, because that's what is doing now by the most housing authorities. Lastly, this project will also help increase the effectiveness of the cockroach IPM programs, because we can use the trap counts data to determine when and where to treat the cockroach infestation. Thank you.
Okay, great. Thank you, Changlu. Very interesting. I have some questions, but I'm not going to ask them at this point. I'm just going to note that I think the social aspect of what you're doing is really important, and I hope we'll have some discussion here at our first Q&A session. But we're going to move along to our next presenter, Charles Lubelczyk from the Maine Medical Center. And this is a project funded by the Northeastern IPM Center, and the title is Manipulation of Winter Soil Conditions as an IPM Tool for Blacklegged Tick. So Charles, if you're ready, go ahead.
Yes, I am. Thank you. Can you hear me?
Yes.
Okay. So our study was conducted in cooperation between the Maine Medical Center Research Institute in Scarborough, Maine, and the Connecticut Agriculture Station in New Haven. We did this partnering with Drs. Kirby Stafford and Scott Williams. And the premise behind this was to take a look and see what would be the beneficial value of having a large snowfall pack on the habitat to look at survivorship of initially Ixodes scapularis. However, we expanded in the second year of the study to include Amblyomma americanum, the Lone Star tick, which is a tick that seems to be moving up the coast of the Northeast. However, historically, Amblyomma has always been regarded as a warm weather tick, a very warm climate adapted tick. And so looking at the potential benefit of snow relative to its survival might give us some insight as this tick moves further north. The two study sites in question were wooded habitats dominated by second growth deciduous forest in New Haven, Connecticut and Cape Elizabeth, Maine. Going to slide 2, please. So what happened, we placed enclosures at ground level with the top just about on parity with the surface of the ground. In each enclosure were placed several vials of live Ixodes scapularis in year 1. And in year 2, we added Amblyomma americanum to them. Scapularis were the nymphal life stage. Amblyomma were the adult life stages, both males and females. These are placed in enclosures under a variety of treatment conditions. The conditions which you can see on the graph present include enclosures where leaves were allowed to remain in place and snow was also allowed to remain in place. Second treatment was simply removing leaves but allowing the snow to remain on the enclosures. Third treatment was no leaf removal. However, we did remove the snow. And then finally, the fourth treatment was a removal of both snow and leaves in both 2016 and 2017. From the graph on the left of the screen, the top graph is actually representing the Connecticut data. Graph underneath represents Maine data. And you can see that overall, we had a much higher survivorship of scapularis at the Connecticut sites. We certainly did see survival of scapularis at the Maine sites, but overall, the slightly colder conditions present were probably more inimical to the ticks in Maine than Connecticut. You can see as well from the pictures placed on the right of the screen some of the problems we ran into with the study. The study started in the winter of 2015-2016. The genesis for this project actually came about in the previous winter, where at least in the Northeast, we had fairly high record levels of snowfall during the winter. However, starting in 2015-16, our snow levels were quite small. And you can see from the photos the dramatic difference that can occur at the sites over the course of a few days. And I'll at least point out to the bottom two pictures, looking at a difference between January 9th, 2017 and January 13th, 2017, you can see the snow has almost disappeared because of the mild winter conditions that we dealt with. If you scroll to slide 3. So the left side of the screen, you'll actually see a map showing the placement of the two study sites and with a small caption overhead indicating the overall survival of Lone Star ticks. And you can see based on this data that there was a much higher survival of Lone Star ticks at the Connecticut sites. 38 to 69% of adult Lone Stars survived, whereas in Maine, only 7 to 9% of those ticks survived any of the overwintering conditions. Now, the strange thing is, the party line really is that Amblyomma is not able to survive in northern New England. The general assumption has been that it is overall too cold for this, but this data indicates that in certain conditions, we do have conditions that are favorable for the survival and possible successful establishment of Amblyomma if they arrive in this area. Again, looking at the graph on the right, or the two graphs on the right, Connecticut at the top, Maine at the bottom, and you can see that overall there was a wide variety of survival among the different treatments. However, for the Lone Stars, we tend to see that the scale is much different, but again, overall, Connecticut has a much higher versus Maine, much higher survival. And that's pretty much what I have at this point. And this, I should say also that this project, even though we were funded for 2 years, the project will be going into a third year that we're going to be doing as a pilot study to kind of continue and expand the data set on this, hopefully actually having a real winter this year up in Maine so we can actually test real snow. So
right, that's
right.
That's really interesting. Thanks, Charles. I know that I've been involved in that, and I was always interacting with the snow and the weather and how that works. But I think what'll be interesting is to watch this progression as things could move further north with changing climates, and hopefully that'll be an aspect of your research that you continue.
That's what we're hoping to do. Yeah, and we're going to be also looking at things like snow depth and annual and daily mean temperatures to see if there's any influence on that as well.
Great, great. So thank you. We'll move on to Quan Zeng, and he is with the Connecticut Agricultural Experiment Station as well, and his project is through the Northeastern IPM Center, Evaluation of Organic Management Options for Fire Blight in Connecticut. So Quan, go ahead.
Can everybody hear me?
Yes.
Thank you for the opportunity. So today, the goal of the research I'm presenting today is to evaluate the efficacy of different organic materials in controlling fire blight. So a little bit background of this research. Fire blight is a devastating disease of many rosacea species, such as agriculturally important crops such as apple and pear. And the controlling of this disease using an organic way is challenging, as number one, the humid climate in the eastern parts of the United States made the disease pressure higher, and lots of the biological controls that have been developed have not been working with high efficacy and high consistency especially in New England region. And also after 2014, originally the organic growers were able to use antibiotics in controlling this disease. But after 2014, this material was removed from the management list. So the organic materials that we are testing for this research refers to both biological control agents as well as some organic chemicals, as we can see from the first slide. For the biological controls, we tested three. So can you stay on this slide, please? For the biological controls, we tested three existing products listed on the table here. Bloom time biologicals, which with the Pentoya agglomerates as the active ingredient. Blossom Protect, which is a yeast product, as well as double nickel, which is with bacillus in this product. Also, we tested organic chemicals such as Cueva, which is a copper product, and Oxidate, hydrogen peroxide sanitizer. And we also included some of the combinations of both biological controls as well as the organic chemicals. So we sprayed this treatment during bloom on red delicious trees at different timing, and then we evaluated the percentage of the diseased apple flowers in the total number of flowers. And we compared the efficacy of this treatment with water and streptomycin. Next slide, please. So as we can see from this chart of the results from the 2017 field trial, from left to right, first we can see that the streptomycin was able to significantly reduce the fire blight disease incidence from roughly about 62% as the water control to about 20%. And then the Cueva and Oxidate, those two organic chemicals, were also able to reduce the disease incidence when they are applied alone. But as we can see, the efficacy was not as nearly as good as the streptomycin, the traditional antibiotics. And BT in combination with Cueva and Oxidate, BT means bloom time biological, they do not have a significant reduction of the disease incidence. Somehow it increased the disease slightly, but also so does the double nickel. So that suggests that those biological controls have not yet been able to work very well as the organic management as previously observed. However, when we look at the BP, Blossom Protect, and the CT1, which is a biological control we isolated in Connecticut in a recent study, we can show that both product were able to reduce the disease incidence significantly. And this reduction can be further enhanced when those products were combined with Cueva and oxidate. So, so I don't think I have enough time, but I listed some of the conclusions on the next slide.
Yeah, so Quan, I'm just going to say that that your results are very interesting, and I know I don't want to cut you off here, and I think we'll leave this slide up just for people to read, but I'd like to move on, but I would like to say what's interesting is in your results is it looks like there's some new potential products, and that will be, you know, I think valuable to growers as we go forward.
Yes, that's the goal. Thank you.
Great, thank you, Quan. So we're going to move on to our fourth speaker for this before our break or our discussion section, and this is Peter Jentsch, and he is from Cornell University, and this is a Northeast NESARE project entitled "A Behavioral-Based Approach to Managing the Invasive Brown Marmorated Stink Bug." So Peter, go ahead.
Great, thank you, Steve. Can you hear me all right?
Yes.
Excellent. So this concept was developed by Ann Nielsen in Rutgers, and it focused on the reduced use of insecticide applications by focusing on perimeter applications in orchards in order to manage the brown marmorated stink bug. So a little bit of background, and starting from left to right on this front, very busy slide. The insect was first found in '97, emerged as a pest in 2010. We've seen significant losses in both conventional and organic tree fruit, small fruit, vegetable crops, soybeans, corn, and so on. It's now found in 44 states in the union, and it's over 100 host plants that the insect can impact. So looking at the egg mass, the females lay about 28 eggs in a cluster. It's the upper left image, and almost always on the underside of leaves, and the insects begin green, start to change to white as they emerge. The first instar is the only instar stage that does not feed on plant hosts. It actually feeds on the egg chorion and other symbionts in order to develop, moving through 5 instars. After becoming an adult, it can produce anywhere from a single to 2 generations in New York State, which really is a game changer depending on the year with regards to population increase. The very bottom of that cluster of slides is the green stink bug. And so when we run our forensics in studying the amount of damage we see at the end of the season, we can't really differentiate at this point between green stink bug injury to fruit and brown marmorated stink bug. They're both arboreal pests, and they both tend to be edge insects. So at any given season, it could be one or both of the insects on the tree. The synthesized pheromone is used in the Tetris trap, which you see there in the middle slide. And we use that to monitor the insect during the season. That slide below the trap is the seasonal progression of the insect from early spring to the end of the summer. The arrows represent the threshold of 10 adults per trap per week. And so in 2012, which this slide represents, there would have been on this orchard numerous applications made for the insect. The upper center slide of the dimpling on the fruit is caused by insect feeding, and so we use that trap and the thresholds in order to trigger applications. In order to communicate to the growers, we use EDD maps in order to represent the counties in which the stink bug is above threshold. So on the bottom right, that image, the Google image there, represents a single block of Pink Lady in which we had migration from the edge of the field into the block in 2012. And you can see the bars on the left side of the graph in the upper right-hand corner represent the edge feeding of the insect in the first 30 feet. And as you move through each of those 30 feet segments, you see a reduction in the amount of feeding along the edge. So the backbone of this project is really to focus on the brown marmorated stink bug along the edge of the orchard in order to reduce that level of damage that we see in some years when populations are high. So the next slide represents an orchard that we looked at in 2016. Now I must say that this was a year where the populations were very low. And so we did not reach the 10 adult per trap threshold during that year. The grower applied a sale, which is an IRAC class 3 insecticide, a neonicotinoid, and it's used at the latter part of the season for apple maggot and culling moth management. So the sale was applied on a 14-day schedule, and along the edge, we applied bifenthrin at the highest labeled rate, only to the southwest corner, represented by the red bars along that edge of the block. And so the data then was collected on Red Delicious, which is a late variety, at harvest along those 4 sampling zones that you can see there, 1 through 4. We split the block and then took the data from that variety. So the last slide simply represents the treatments of a sale with bifenthrin in the 2 bars on the left compared to a sale alone in the center sample block and a sale alone along the edge. Statistical differences are only between the bifenthrin and a sale along the outside northern edge of the block. And as you can see numerically, the damage levels were considerably lower where bifenthrin was applied, and where we just had a sale in the center of the block compared to sale along the edge, we had significantly higher levels there. And so we do think that this is a management strategy that the growers can use on a yearly basis in order to reduce the amount of insecticide and hopefully reduce the amount of disruption that takes place late in the season with pyrethroid use, to be able to maintain predatory populations of phytoceid mites and other predators that tend to build later on in the season. So that's about all I have, Steve. Thanks for your attention, everyone.
Yeah, great. Thanks, Peter. So I just wanted to ask, you have behavioral-based approach. Is that behavior of the stink bug? Is that looking at, what is that exactly?
So, yeah, I should have touched on that a little bit further. The behavior of the insect I tried to demonstrate in the first slide in the bottom right-hand corner, where they migrate from along the wooded edge into the orchard, and they reside in highest numbers and cause the most damage to the fruit along that edge. So,
so you're looking at how the insect moves.
It is really based on the migratory activity and where they tend to be present in a block of tree fruit, and that holds true for soybean as well.
Okay, good. That's kind of what I was thinking, but I just want to clarify, because I think, and just looking at all these 4 talks this morning, I think it's interesting to look at, whether we're talking about, fire blight, disease, whether we're talking about ticks or cockroaches, looking at how those pests respond. And I think that's kind of what you guys, is what I've heard, at least this morning. And unfortunately, we've got 2 minutes, and I'm looking at the Q&A, and there are no questions. So I guess we could, I guess the one thing that I'm noticing here is that this is kind of on an IPM continuum, and whether you're talking about, we're introducing something, a control treatment with stink bug, or whether it's an organic, product for fire blight, it's kind of introducing, here's a practice that can really add to your IPM toolbox moving forward. So I think that's great. And without I don't want to go into this too much because I want to keep on track here, but that's kind of what I'm seeing is what you guys are doing, and I think that's really valuable. So thanks again for you first 4 speakers, and please stay around because if we do have questions as we go forward and someone wants to ask something on a previous talk, that's completely allowed. So feel free to do that. But we're going to move right into our 10 o'clock section.